All right, let's look at the homework 11.2, problem number 5. All right, so let's determine whether this series is convergent or divergent. All right, first thing I would do is I'm going to split into two series. So here, first one is summation. N goes from 1 to infinity. All right, and I'm going to write it this way. So 4 in front. And then I'm going to write 1 over e to the nth power, right? It's the same thing, right? And the second part, I'm going to actually pull 2 out. Then we have a summation. N goes from 1 to infinity. Then you have 1 over n times quantity n plus 1, right? Then you notice that the first one is is a geometric series, so we just have to find the a value. So a value in this case is just the first term. So you have 4 times 1 over e to the first power. So it's going to be just a 4 over e, right? Then our value is looks like a 1 over e, right? So since the absolute value of r is going to be 1 over e is less than 1, so we're going to have a convergent series. So the sum is a, which is 4 over e over 1 minus r. R is 1 over e. All right, so the first part is convergent and then converges to this particular sum. All right. And if you look at the second one, this is actually a telescoping series. All right, so we need to find the a partial sum first. All right, before, maybe we need to do a partial fraction here. So I'm going to look at the 1 over n times n plus 1. All right, we can split this into a over n plus b over n plus 1. All right, so we can just put them back together. So you have a n times n plus 1. Then you have a times n plus 1 and plus b times n. All right, so we need to match this numerator on the left and the numerator on the right. Right, so easiest way is if you want to find a, I'm going to get rid of b by setting n equal to 0. Right, so it's a times 0 plus 1 is a, and b times 0 is 0, and this has to be equal to 1. Right, so a is equal to 1. And if you want to find b, we can set n to be, say, negative 1. Then you can see that it's a negative b is equal to 1. Right, then we can multiply by negative 1. Then we have a b value, which is a negative 1. All right, so we have this telescoping series here. All right, 2 times, all right, you have a summation. All right, n goes from 1 to infinity. All right, then it's going to be a is 1, so it's a 1 over n. B is negative 1, so it's a negative 1 over n plus 1. All right, so let's find the partial sum of the telescoping series. So Sn is going to be, so when n equals 1, we have 1 over 1 or minus 1 over 2. When n equals 2, you have 1 over 2 minus 1 over 3. And plus, when n equals 3, 1 over 3 minus 1 over 4, and so on. Then second to last one would be 1 over n minus 1 minus 1 over n. And the nth term would be 1 over n minus 1 over n plus 1. All right, then you can cancel. You have a positive 1/2. There's a negative 1/2 and positive 1/2. Negative 1/3, positive 1/3, negative 1/4, and there's going to be a positive 1/4 there. And there's going to be negative 1 over n minus 1, and then there's a positive 1, negative 1 over n, and here is n. All right, so there are only two terms left over, the very first term and the very last one. So the partial sum simplifies to 1 minus 1 over n plus 1. All right, so this is going to be, all right, so first guy, I'm going to actually multiply top and bottom by e so that it looks a little bit better. So you have a 4 here over e minus 1, all right, plus 2 times. Now we have to take the limit of the partial sum. All right, partial sum of this telescoping series is 1 minus 1 over n plus 1 as n approaches infinity. Right? This is a simple limit to evaluate because this guy simply goes to 0, right? 1 divided by a big number. All right, so this is going to be, first term is 4 over e minus 1, and the second term is 2 times 1, so it's 2. All right, so this is the sum. So the series converges, and then the sum is 4 over e minus 1 plus 2. All right, so let's type it in. All right, so it's going to be a convergent, and this is going to be 4 over e minus 1 plus 2. All right, so let's check the answer. Submit for testing. All right, looks like we got this one correctly. All right, that's it. I hope that this was clear.